We're going to be continuing Chapter 1, Section 1 today, and so remember we're just brushing up or dusting off our brains on a few of these skills that we've learned in the past, but we'll need to be able to do again. We're going to be doing examples 3 and 4 today, and we're going to be starting with example 3, which is going to remind us how to divide with whole numbers, and these problems you're going to be doing today don't have any remainder, and we'll be tackling remainders later on in the year. The question says, you make 24 equal payments for a go-kart. You pay a total of $840. How much is each payment? And since we're starting with the whole amount here, the total of $840, and we're trying to break it into 24 equal payments, we know that we're going to be doing some division. So we're going to go ahead and set up our division problem. And to kind of remind you, we have a couple of parts of a division problem that we're going to want to get to know. So the 840 that we have under the box, so to speak, is called our dividend, and then our 24, which is outside the box, is known as the divisor. And then we're going to put the answer up here, and that's called our quotient. We are going to add those words to this first sample problem just to remind ourselves of those vocabulary words, but you're not going to have to write those in every time. And then, since we're dividing by a 2-digit number, we have to ask ourselves if the 24 can go into 8, which of course it can't. So some people put an X, or some people put a 0 to remind themselves not to use that place value, and remember that's the hundreds place value, and then they go on to see if 24 can go into 84, and 24 can go into 84 around 3 times without going over it, and you can do some estimating if you need to do that to figure it out. Remember, 24 is pretty close to 25, so if we were to count by threes, 25, 50, 75, we couldn't get one more group in there. So we're just going to estimate, and 24 times 3 is 72. And again, do the side math if you're not sure about that. 4 minus 2 is 2. 8 minus 7 is 1. And then we're going to come to that next step here to remember to bring down that 0. And when we do that, that gives us 120. And now we're going to see if 24 can go into 120 times, or a better question would be how many times it's going to go in. And again, we can kind of do some estimating. So 24 could go into 104 times. It wouldn't be able to go into 120 many more times, but since it wasn't 25, it was actually 24. We're going to see if we can get it to go in about 5 times. And if it doesn't work, we can always go back and readjust. So if we do the side math, 5 times 4 is 20, and 5 times 20 is 100, so we'll add all those together. And again, that was just a shortcut in thinking. You would be more than welcome, and it would be encouraged for you to actually do the side math and multiply 5 times 24 to make sure that you understand where we got that. But when you see what we did there, you can notice that the 120 is going to leave us with no remainder, and I just kind of squeezed that 0 in there. But 120 minus 120 is 0, and since there's no remainder, we don't have to go any further with the problem. So in this case, that tells us that each payment would be $35. Alright, now you're going to do a couple of problems to try it, and these are the on your own problems from page, looks like that's page 6 in big green, and They do ask you to find the value of each expression. And again, remember that just means find the answer here. And it does remind you can use estimation to check your answer. And again, that's a great skill to have in your back pocket, but I'm not going to have you write any of that down if you don't want to. Feel free to try it. I did this first time around give you a couple of reminders because when your problems are set up this way instead of already in the box for you, then you need to remember what order things go in, because in division it really does matter where you put things. And so when you have the problem for division set up this way, the first number is always the dividend. And remember, the dividend up here goes in the box or under the box always. And the second number is always your divisor, and that one always goes outside the box. When you have the problem set up this way, top and bottom, that top number is always that dividend, and again, goes under the box. And then that bottom number is always the divisor, which always goes outside the box. So it is important that you put things in the right place. Now you're going to go ahead and give these on your own problems a try. And remember, in a few minutes when you're done trying all three problems and coming up with an answer, then you'll get a chance to see if you have correctly answered them. There are your answers for the on your own problems on page 6. Now, if you are following along in big green, you might have noticed that the on your own problems do have a number 7 with them, and I didn't include it. Of course, you're more than welcome to try it if you want to, but sometimes we just pick and choose a couple of problems to practice that new skill. So we just did 4, 5, and 6 this time, and those are the answers here. If you're interested in the number 7 answer, you're welcome to come see me after you've done it, and I'll be happy to check it over with you. Example 4 is called a real-life application. So this tends to be a word problem or some reason that you might actually use this particular skill. So the question says, a 301-foot high swing at an amusement park can take 64 people on each ride. A total of 8,983 people ride the swing today. All the rides are full except for the last ride. How many rides are given? And there is a second part, how many people are on the last ride? So when you're reading these kinds of problems, you have to look at all of the information they give you. And in this case, you might notice that they give you a piece of information that you don't need. And specifically, you really don't need to know in this problem to solve it how high that swing is. So I'm going to take my pen and I'm just going to cross that piece out so I don't use that piece of information. Not all problems will do that, but some do, and you always have to be on the lookout for that extra information. It is looking like a division problem, though, because you have a total number that you start with, 8,983 people, and each ride can take 64, and we're trying to figure out how many rides they gave. So we're taking that whole number of 8,983, and we're going to split that up or divide it into the 64 people that can go on each ride, and we're going to see how many rides were given that day. And then we'll go ahead and tackle that last question. So again, we're going to use that skill of just kind of estimating here, 64, and it can't go into 8, but it can go into 89, and it can go in one time. So I'm going to remember to put that 1 right above the 9 because I don't want it over that thousands place value. I don't want it over the 8. And again, if it helps you to put in a little placeholder X or a 0, you're more than welcome to do that. Otherwise, if you just line everything up carefully, that should work too. And then 1 times 64 is 64. So we're going to put that under here, and we're going to go ahead and do our subtraction. 9 minus 4 is 5, 8 minus 6 is 2. A good check step is to always stop when you did your subtraction and check to make sure that that number you got after subtracting is less than that divisor, because if it is, you know you couldn't have gotten an extra group in. If it's bigger, then you might have to go and adjust the number up here to a bigger number. But in this case, 25 is less than 64, so we're going to go to the next step, which is to drop that next digit, and we're going to put the 8 right next to there, and we're going to figure out about how many times 64 can go into 258. And again, you can do some estimating. 64 is close to 60, 258 can be rounded to close to 250, which doesn't help us as much as you'd think, but you could even go down a little farther to about 240. And 60 could probably go into 240 about 4 times. So I'm going to use that as my starting point. Again, on your paper, I'm going to show you this time to remind you, if you have to do some side math and you have to check yourself, make sure you give yourself plenty of room and do 64 times 4 and see if that gets you close to where you want to be. And in this case, that gets us pretty close because that's going to give us 256, and we were trying to get to 258, so that's pretty close. And so now we're going to put that 256 under here, and we're going to subtract. 8 minus 6 is 2, and again 5 minus 5 is 0, and 2 minus 2 is 0 also, so you can put them in or you can leave that. 2 is definitely less than 64, so we know we couldn't have gotten a bigger group in. So we're going to go to that last step of dropping that 3. And this does get a little bit tricky, and some kids miss this step, so make sure you remember how to handle this. We have to ask ourselves, how many times can 64 go into 23? And since we already dropped that 3, we can't drop any extra numbers. We have to see if 64 can go into 23, and since it can't, we have to make sure that we put 0 up there in our quotient, because 64 goes into 23 0 times. And then we continue on. 64 times 0 is 0. Of course, anything times 0 is 0. And we do the subtraction, and we have 23 left over. So in this case, there is actually a remainder, and you can just write it up there for right now, remainder of 23. And later on this year, we'll talk about different ways that you can handle remainders, but we're going to go up and we're going to check out our question. So we have to figure out what this means. So our original question was, how many rides are given? So what this tells us is that 140 rides were given, and then we're going to remember that there was also this other question up here. Whoops, sorry about that. How many people are on the last ride? So in this case, you could get 64 people on each ride 140 times, but it told us that on that last ride it wasn't full, and there were 23 people that were on that last ride, or left over, so to speak. So that remainder helps us answer that last question. 23 people were on the last ride. All right, and that's it for the real life application. Now that we've gone through all of the examples in Chapter 1, Section 1, you're going to do a little bit more practice, and you're going to go to RapJ page 6, and remember we started that with the first video. We did numbers 1 through 6. And you'll notice this time that I'm not having you just do all of the problems on the page. I'm going to have you do numbers 7, 8, 10, and 13, because the long division can take a little while. And so we're going to just kind of cut down the number that we're practicing for today. But there are a few problems that are not being assigned, like numbers 9 and 11 and 12, and if you are wanting more practice to make sure you're understanding the long division, then you're more than welcome to do those. But the ones you need to do from RapJ page 6 are 7, 8, 10, and 13. And 13 is a word problem, so remember to make sure to put a label on that one.